Hello students. Now it's fifth lesson on chapter 8 Introduction to Trigonometry. In this chapter today we are doing our next topic, trigonometric identities. You have done in class 9th also algebraic identities. What is an identity? An equation is called an identity if it is true for all values of the variable or variables involved. Similarly, trigonometric identities we can define as an equation involving trigonometric ratios of an angle theta. It is said to be trigonometric identity if it is satisfied for all values of theta for which the given t ratios are defined. Now today in this chapter, in this topic, we shall establish some fundamental trigonometric identities and we will be using them to prove some more identities in our exercise 8.4. So let us derive these three fundamental trigonometric identities one by one. For that purpose we will consider a right triangle. You can see here right triangle ABC, right angled at B. So we use Pythagoras theorem in this triangle. And we can write AC square is AB square plus BC square. Let this be equation 1. You can see in this equation 1 there are three terms. Square of hypotenuse is equal to square of side AB and square of side BC. Their sum. So if we divide this equation one by these three terms, we will get three fundamental identities. Let us see how. First let us divide 1 by first term is AC square. So AC square upon AC square will be 1. AB upon AC whole square. BC upon AC whole square. Now you can look at the figure. If you suppose that theta is at point A, then what will be AB upon AC? AB is the side adjacent to theta and AC is the hypotenuse. So side adjacent to theta upon hypotenuse is, what is that? Cos theta. So it will be cos square theta plus BC upon AC. Now BC is the side opposite to theta. Side opposite to theta upon hypotenuse is sin theta. So it will be square of sin theta. So here we have got our first fundamental trigonometric identity. Secondly, if we divide equation 1 by second term here AB square, it will become left hand side AC upon AB whole square. AB square upon AB square will be 1 plus BC upon AB whole square. Okay, now let us look at the figure. AC upon AB. AC is the hypotenuse and AB is the side adjacent to theta. Now hypotenuse upon adjacent side is sec theta. So it will be square of sec theta is equal to 1 plus BC is the side opposite to theta. Sorry. Upon AB is the side adjacent to theta. Now opposite side upon adjacent side is tan theta. So it will be tan square theta. Or you can write it as sec square theta minus tan square theta is 1. So this is our second fundamental identity. Now we divide same equation 1 by third term, that is BC square, and we get AC upon BC whole square is equal to AB upon BC whole square plus 1. Now look at the figure. AC upon BC. AC is the hypotenuse and BC is the side opposite to theta. So hypotenuse upon opposite side is cosec A. So it will be square of cosec theta equal to AB. Now AB is the side adjacent to theta and BC is the side opposite to theta. So adjacent side upon opposite side is, this is cot theta. So cot square theta plus 1. Or we can write it as cosec square theta minus cot square theta is equal to 1. So we have got three fundamental identities. First is sin square theta plus cos square theta is 1. By transposing the terms, you can write different forms of this identity as per the need of question. Like from here you can write that sin square theta is 1 minus cos square theta, or you can write cos square theta is 1 minus sin square theta. Or further, if you want value of sin theta, you can write it as sin theta is under root 1 minus cos square theta, or cos theta you can write as under root 1 minus sin square theta. Second identity. Second was sec square theta minus tan square theta is 1, or you can write it as sec square theta 1 plus tan square theta, or we can write that sec theta is under root 1 plus tan square theta. Also, if you want to obtain tan square theta in terms of sec square theta, you can write it as tan square theta is sec square theta minus 1, or you can write that tan theta is under root sec square theta minus 1. Our third identity was, third fundamental trigonometric identity is cosec square theta minus cot square theta is equal to 1, or you can write it as cosec square theta is 1 plus cot square theta, or you can write that cosec theta is under root 1 plus cot square theta. Or if you want to write cot square theta in terms of cosec square theta, then what it will be? Cot square theta will be cosec square theta minus 1, or cot theta is under root cosec square theta minus 1. So you need to learn these main forms of three fundamental trigonometric identities, and by transposing the terms of the equation you can get the other forms also as per the need of your question. So children, keeping in mind these three fundamental identities, secondly algebraic identities which we have done in class 9th, and third relation between trigonometric ratios like tan theta is sin theta upon cos theta, cot theta is cos theta upon sin theta, sec theta and cos theta are reciprocals of each other. Similarly, cosec theta and sin theta are reciprocal of each other, tan theta and cot theta are reciprocal of each other. So keeping in mind all these results, we start our exercise 8.3. In exercise 8.3, question number 1. You have to express the trigonometric ratio sin A, sec A and tan A in terms of cot A. So let us see how we can do it. First we start with sin A. As we know that sin A is reciprocal of cosec A. So sin A can be written as 1 upon cosec A. And what is cosec A? Yes, cosec A can be written as under root 1 upon, it will become 1 upon under root 1 plus cot square A. So here we have got sin A in terms of cot A. Next, sec A. Yes, sec A. Sec A, we can see that sec A can be written in terms of tan A. And tan is reciprocal of cot A. So we start from here. Sec A we write as under root 1 plus tan square A, and tan A can be written as 1 upon cot A. So it will become square, or you can further take LCM within square root, it will become cot square A plus 1 upon cot square A. Or further, if you want to simplify, you can write it as cot square A plus 1 upon square and square root in denominator cancel, so cot A you get. Third, tan A. Now tan A you can directly do because you know that tan A and cot A are reciprocals of each other. So in place of tan A you can write 1 upon cot A. So this is how we have done these three parts. Second question is also same. You can try, children. If you don't get, you can ask your doubt. Question 3 I am doing next. In this question, you have to evaluate. First part, sine square 63 plus sine square 27 degree upon cos square 17 degree plus cos square 73 degree. Yes, in our last exercise, we have done trigonometric ratios of complementary angles. And we know that sine theta is cos 90 minus theta. So in place of sine 63, if we take 63 as theta, we can write sine theta as cos 90 minus 63 square as it is plus sine square 27. Similarly, in denominator also, cos theta can be written as sine 90 minus theta. So here I am writing sine 17 as 90 minus theta square plus cos square 73. In numerator, what is 90 minus 63? It is 27. So it becomes cos square 27 plus sine square 27, and here it was theta, it was 17. So 90 minus 17 is 73. It becomes sine square 73 plus cos square 73. Now let us come to our first fundamental identity. Sine square theta plus cos square theta is 1, and here theta is 27 in numerator. So sine square 27 plus cos square 27 will be 1. Similarly, in denominator also, sine square 73 plus cos square 73 will also be 1. So we get 1 as the value of this given expression. Same is your second part, so that you can do. Now we are coming to our question number 4. In question 4, you have to choose the correct option. It's MCQ, justify your choice. So we will be solving all the parts. Let us start with the first one, and you will learn that how we prove the identity. 9 sec square A minus 9 tan square A. Here we can take out 9 common. First you should look at the question carefully, the expression which is given to you. You can see that if we take out 9 common, we get sec square A minus tan square A. Yes, these identities should be learned by you properly, then only you can apply them. Sec square theta minus tan square theta is what? Second identity, 1. So if we use that, we get 9 into 1, that is 9 is the answer. So option B is correct. Second part, 1 plus tan theta. Second part is given as an MCQ, but this question is mostly asked for 2 or 3 marks. Sec theta 1 plus cot theta minus cosec theta. Okay, if you look at this expression, any algebraic identity can we use? No. Or any of these 3 fundamental identities can we use here? No. We can write these t ratios in terms of sine theta and cos theta. Like tan theta can be written as sine theta upon cos theta. Sec theta can be written as 1 upon cos theta. Similarly, cot theta and cosec theta also we can write in terms of sine and cos. So let us write. It will become sine theta upon cos theta, 1 upon cos theta, 1 plus cos theta upon sine theta minus 1 upon sine theta. And now we simplify. First bracket, let us take the LCM. That is the next possible simplification. So we add by taking LCM. Cos theta plus sine theta plus 1. And in second bracket, sine theta in place of 1 it will be plus cos theta minus 1. So here you can see that we are getting in the numerator, in first bracket we have same type of terms, just one sign is different. So if we consider it to be one term and one as second term, and similarly here also this has one term, this has second term, one as second term, then it is of the form a plus b, a minus b. So we can use algebraic identity. A plus b, a minus b is a square minus b square. So we can write it as cos theta plus sin theta a square minus b square upon sin theta cos theta as it is. Now here we can use a plus b whole square and we will get sin square theta plus cos square theta plus 2 sin theta cos theta minus 1 upon sin theta cos theta. Now what was our first fundamental identity? See here, sin square theta plus cos square theta is 1. So sum of first two terms we will write as 1 and rest of the terms as it is. One and minus 1 are cancelled and we are left with 2 sin theta cos theta upon sin theta cos theta, and we are getting 2 as our final answer. So that means in second part option C is correct. Now third part of question number 4, sec A plus tan A into 1 minus sin A. Here you can see that no identity we can apply here in the beginning. So let us write sec A and tan A in terms of sin and cos. So sec A we can write as 1 upon cos A and tan A we can write as sin A upon cos A. Second bracket as it is. Now in first bracket if we take LCM cos A, it will become 1 plus sin A into 1 minus sin A as it is. Now you can see in numerator we are getting, which form we are getting? A plus B into A minus B. So we can use A square minus B square and it will be 1 square minus sin square A upon cos A. So 1 minus sin square A is what? Look at first identity. 1 minus sin square A is 1 minus sin square theta is cos square theta. So 1 minus sin square A will be 1 minus sin square will be cos square A upon cos A. So what we are getting? Cos A. So in third part D is the correct option. Fourth part let us discuss now of question number 4. 1 plus tan square A upon 1 plus cot square A. Yes. Any identity? Yes. 1 plus tan square A. See here. Second identity. Sec square theta minus tan square theta is 1. From here we have got that 1 plus tan square theta is sec square theta. So in place of 1 plus tan square A we can write sec square A. Similarly, third identity gives us that 1 plus cot square theta is cosec square theta. So here we can write cosec square A. To simplify further, sec square A we can write in terms of cos A, or we can write it as into 1 upon cosec square A. Now sec square A is, it can be written as 1 upon cos square A, and 1 upon cosec A is sec square, 1 upon cosec A is sin A. So it will be sin square A. Further you can write it as sin square A upon cos square A, which is tan square A. So that means option D is correct. Okay children, so go through all these notes carefully, understand, and if any problem in any question you can ask me through WhatsApp, and we will continue this exercise next time. Okay children, thank you.